Hi everyone, let's solve this problem. Prove that if a, b, and c are odd integers, then the roots of the given quadratic equation cannot be rational. Go ahead and pause the video and give it a try. We'll begin by letting a equal 2u plus 1, b 2v plus 1, and c 2w plus 1 for some integers u, v, and w. Well, the roots of the quadratic equation will be rational if and only if the discriminant b squared minus 4ac is a perfect square. Well, we can substitute the above expressions for a, b, and c and compute that the discriminant is equal to the following: 8 times v plus 1 over 2 minus 2uw minus u minus w minus 1 and then plus 5. If you'd like to pause the video and verify that, go ahead. Now I'd like you to notice that either v or v plus 1 must be an even number, and therefore v times v plus 1 over 2 is an integer. So the entire expression in the parentheses is an integer. Therefore, b squared minus 4ac has been written as 8 times an integer plus 5. And so b squared minus 4ac is odd. Okay, it's an odd integer. Well, if it's going to be a perfect square, it can only be the square of an odd integer. And we're going to show that that is actually impossible. Okay, well, we're going to begin by noticing that every odd integer has the form 4k plus 1 or 4k minus 1 for some integer k. In other words, every integer is either one more or one less. Every odd integer is either one more or one less than a multiple of 4. Well, if we take integers of the form 4k plus 1 and square them, we get 16k squared plus 8k plus 1, which can be written as 8 times 2k squared plus k plus 1. So odd integers of this form are 1 more than a multiple of 8, not 5 more than a multiple of 8. Okay, well, take a look at odd integers of the form 4k minus 1. That would be 16k squared minus 8k plus 1, which is 8 times 2k squared minus k plus 1. So again, we get 1 more than a multiple of 8. So the square of every odd integer is 1 more than a multiple of 8, and therefore cannot equal the discriminant. So the roots are non-rational. Thanks for watching the video.